What is common between a packet of silica gel, a car engine, and a gas mask? These do not look similar on the outside. However, if we look internally, a similar phenomenon happens to the three of them. Inside a silica gel packet, in the gas mask filter, and on the walls of a car engine,
adsorption takes place.
IUPAC defines adsorption as the enrichment of molecules, atoms or ions in the vicinity of an interface.
Silica gel is an effective drying agent because water molecules adsorb into its pores.
Activated carbon and gas mask filter adsorb toxic components in the air due to its porosity and high surface area. On the walls of the catalytic converter of a car engine, pollutant gases are converted to safer ones.
Adsorption, such as in gas mask filters and silica gel packets, is physisorption, which is caused by intermolecular forces.
In the case of the catalytic converter in engines, chemical adsorption or chemisorption happens. The adsorbent and adsorbate form chemical bonds. Researchers use isotherms to characterize physisorption. Type 1 isotherms are reversible and the amount adsorbed has a limiting value. The isotherm is increasing at low pressures but approaches the limiting value as pressure increases. The slope of type 1A isotherm at low pressure is less steep. This is associated with materials containing mainly narrow micropores with widths less than 1 nanometer.
Type 1B isotherm at low pressures have steeper slopes. It is associated with materials having micropores with widths less than 2.5 nanometers. Type 2 isotherms are reversible. This isotherm also shows that the adsorption is multilayer. If the bump in the graph is slight, monolayer adsorption happens simultaneously with multilayer adsorption. Type 3 isotherm looks similar to Type 2 isotherm at high pressure range. There is no bump in the isotherm, hence, monolayer coverage is not distinct. Type 4 isotherms have two bumps. The first bump, similar to Type 3, shows the point when monolayer coverage transitions to multilayer coverage. Type 4A isotherms exhibit hysteresis, a phenomenon when the forward process, in this case adsorption, does not coincide with the backward process, or desorption. Type 4B isotherms are reversible and do not exhibit hysteresis. This is associated with adsorbents containing conical and cylindrical mesopores. Type 5 isotherms look similar to Type 3 isotherms in the low pressure range. As pressure is increased, adsorbate increases rapidly and plateaus at a maximum amount of adsorbate. Lastly, Type 6 isotherm shows reversible layer-by-layer adsorption. The height of each step represents the capacity of each adsorbed layer. The sharpness of each step depends on the system and temperature.
Isotherms that exhibit hysteresis are Type 4A and Type 5. Commonly, hysteresis loops are observed when capillary condensation happens. According to IUPAC, there are 5 types of hysteresis. Each one shows a very steep slope at the loop. The adsorption branch is at a higher pressure than the desorption branch, though slopes for both are almost equal. Each phase is similar to a Type 2 isotherm. The absorption branch lower limit is at cavitation-inducing pressure. H for absorption branch appears like a mix of types 1 and 2. In H5 loops, adsorption and desorption branches curvature shift twice. They are characterized by sharp step-downs. Today, we learned about adsorption, isotherms, and hysteresis. Adsorption can be physisorption or chemisorption. Intermolecular forces are formed in physisorption, while chemical bonds are formed in chemisorption. There are 6 types of isotherms and 5 types of hysteresis. We hope you enjoyed. Till next time!
Created using Powtoon.